Hello everyone, welcome to my class. In today's class we are going to start chapter 7, and in today's class I am going to cover section 7.1, the oblique triangle and the law of sine. So let me begin the class right away. First let me give you an overview of chapter 7. In chapter 7, as an application of trigonometry, we study two laws, the law of sines and the law of cosine. These laws can be used to solve oblique triangles. Oblique triangles are non-right triangles. So we solve right triangles using trigonometric functions, and to solve non-right triangles we use the law of sine and law of cosine. In this process, the laws require that we have three parts of the triangles known in order to solve for the fourth. The possibilities are as follows. In the sine laws, we have the triangles ASA-Triangles, AAS-Triangles, SSA-Triangles. Here, ASA stands for angle, side, angle. AAS stands for angle, angle, side. And SSA-Triangle stands for side, side, angle. So quick visualization here. This is ASA triangles where side is in between two angles. Next, AAS triangles, angle, angle, and then side. In the first case, side is included between angles. In the second case, the side is outside those angles. And third case, SSA, here side, side, and angle. And in the cosine laws, in next sections we will cover SAS triangles and SSS triangles. So here SAS stands for side, angle, and side. The diagram is here. SAS, here is the side, and angle and side. Angle is included between two sides. And SSS triangle stands for side, side, side. So these 5 cases we investigate in sine laws and cosine laws in section 7.1 and in 7.2. Great. Now quick remark before starting the section 7.1. Let me scroll down. When solving the triangles, remember the following facts. The sum of all angles of a triangle must be 180 degrees. The sum of any two sides of a triangle must exceed the length of the third side. Longer sides are opposite larger angles. Equivalently, smaller sides are opposite to smaller angles. Trigonometric functions can only be applied for right triangles. So, to solve non-right triangles, we use either the sine laws or the cosine laws. Part E. The trigonometric equation sin theta equals to k for k between 0 and 1 has two solutions. Solutions lies either in first quadrant or in second quadrant. We know the range of inverse sin theta is minus pi half to positive pi half, included both pi halves. That means first quadrant and second quadrant. But for sin theta equals to k and k is strictly greater than 1 has no solutions, because the sin theta has maximum 1 and minimum minus 1. Great. Now let's begin section 7.1. So first let me give you the laws of sine. For any triangle ABC, so here in the diagrams, ABC triangle, we have these ratios are equal. And in this triangles, in the triangle, the opposite side of angle A is denoted by lowercase a. The opposite side of angle B is denoted by lowercase b. Similarly, the opposite side of angle C is denoted by lowercase c. So in this triangle, these ratios are equal. So sine A over little a equals to sine b over little b equals to sine c over little c. Equivalently, if you flip these ratios, then we will have a over sine a equals to b over sine b equals to c over sine c. By the way, to find angles, we use this first sine laws, and to find the sides, we use this equivalent expressions of the sine laws. Great. Now let's move on. Next, some side notes for the laws of sines. The sine laws cannot be used in the cases of SAS and SSA triangles. For those cases, we need to apply the laws of cosine, which we cover in next sections. The SSA case is called the ambiguous case of the law of sines because it may result none or one or two solutions. Side note number 3, some applications of the laws of sine involves finding planetary distance between cities and the height of a mountain. Now let's begin solving some examples. Let me scroll down. Example first, part A. The given equations is sine 52 degree over b equals to sine 32 degree over 12. Now let's find the value of b. Solutions, cross multiply here. So 12 times sine 52 degree equals to b times sine 32 degree, which I did here. I wrote first b times sine 32 degree equals to 12 times sine 52 degree. Our goal is to find the value of v. So let's divide both sides by sine 32 degree. Then we have b equals to 12 times sine 52 degree over sine 32 degree. And using calculator, the approximate value of b turns out to be 17.84. Awesome. Similarly, let's move on. Let's do part B. Sine 60 degree over 32 equals to sine b over 9. So this time we are solving for angle B. And also the questions ask us to determine if a second angle theta between 0 to 180 degree exists and satisfies the equations. Great. So now first let's find the value of b. Begin the solutions, again cross multiply. So here 32 times sine b equals to 9 times 60 degree. We are finding the value of b, so let's isolate sine b alone to the left hand side. That means divide both sides by 32. So then sine b equals to 9 over 32 times sine 60 degree. And in the next step, we know sine 60 degree is radical 3 over 2. Then using calculator, let's simplify. Then sine b turns out to be approximately 0.2436. Hence, to find the value of b, multiply both sides by inverse sine. Then we will get angle b equals to approximately sine inverse 0.2436 using calculator, which turns out to be approximately 14.1 degree. So we found the value of b is 14.1 degree, and another possibility is b equals to 180 degree minus 14.1, which is 165.9 degree. Great. Then the last part here, the questions also ask us determine if a second angle between 0 to 180 degree exists and it satisfies the equations. But this relations here, it says no, second angle is not possible because 60 degree is already given to us. So 60 degree plus 165.9 degree turns out to be greater than 180 degree. it violates the note number 1 here I gave you earlier. The sum of all angles of a triangle must be 180 degrees. So then no second possibility exists. Awesome. I hope this question and answer makes sense to you all. Now let's move on. Now example 2. Solve the triangle with side. Given side is C equals to 12.9 meter, angle A equals to 20.4 degree, and angle B equals to 63.4 degree. So two angles are given and one side is given to us. Then we need to find out third angle. Here the angle is C, and other two sides, side little a and side little b. I hope it makes sense to you all. In the triangles we have three angles and three sides. Great. So let's begin the solutions. So to find the angle C, we know angle C equals to the sum of the total angles of triangles is 180 degree minus sum of these two angles A and B. Simplify, which turns out that angle C equals to 96.2 degree. That's one of the solutions. Great. Now we need to find out two other sides, side A and side B. We already know the side C is 12.9 meter. So next, to find the side A, let's apply the laws of sine. So here, we know these two ratios are equal. Side A over sine A equals to side C over sine C. The next step, we need to find the value of A. Let's plug the values of these angles here, and then side. We know angle A is 20.4 degree. We know the side C is 12.9. We know the angle C is 96.2. Next, let's cross multiply here. So A equals to then 12.9 times sine 20.4 degree over sine 96.2 degree. Then using calculator, the side A turns out to be 4.52 meter. Great. Awesome. Next, to find the side B, let's apply the law of sine again. These two ratios are equal. That is, side B over sine B equals to side C over sine C. Let's plug the values here. So B, we are going to find out B. So B over sine of angle B is 63.4 degree equals to side C, we know 12.9 is given to us, over sine of C, angle C is given to us 96.2, we already found earlier. So here, then cross multiply, then B equals to 12.9 times sine 63.4 degree over sine 96.2 degree. Using calculator, it turns out that side B equals to 11.6 meter. Awesome. So we found the value of two sides and one angles. Great. So we finished this example 2. Now let's move on. Now example 3. Here. Use the law of sines to determine if no triangle, one triangle, or two triangles can be formed from the diagrams. Then solve. Note the arrowhead marks the side of undetermined length. So here, so this is the triangle and this side is not determined, and also the angle is not determined. So this one maybe joins here or maybe joins there. We need to find out the value of A, the side A, and the angle B. Great. So now begin the solutions. We need to find out the angles B, this angle here, angle A, and side A. Given angle C and given two sides C and B. Awesome. Now to find the angle B, let's apply the law of sine. These two ratios are equal. Sine B over side B equals to sine C over side C. Let me scroll down. What's given to us? Okay, sine B, we are going to find out angle B. So sine B as it is over side B is 67 equals to angle C is given to us, which is 59 degrees. So sine 59 degree over side C is 58. I hope this makes sense to you all. Next, let me go this way. So then, to find the angle B, let me write the sine B all onto the left hand side. So that means let's cross multiply here. So then sine B equals to 67 times sine 59 degree over 58. Using calculator, it turns out that sine B approximately 0.9902. To find the value of B, multiply both sides by inverse sine. Then next step, angle B is approximately sine inverse of 0.9902. Using calculator, angle B turns out to be approximately 82 degree, or 180 minus 82 degrees is 98 degree. So we have two possibilities for angle B. So here this can be either 82 degree or 98 degree. Then we can easily find the value of angle A, because the sum of angle A plus angle B plus angle C is 180 degree. So 180 degree minus the sum of these two angles, angle B and angle C, gives us angle A. So let me scroll down here. So next, to find the angle A, so here's angle A equals to 180 degree minus 82 plus 59 degree, or angle A equals to 180 degree minus the sum of 98 degree plus 59 degree. So angle A can be 39 degree or 23 degree. I hope this makes sense to you all. And 59 degrees is the given angle C. Awesome. Let's move on. Likewise, now to find the values of the side A, let's use the sine law again. These two ratios are equal. So here the side A over sine A equals to side C over sine C. Then to find the value of A, we know C is given, we know the angle A is given, angle C is given. Cross multiply, so A equals to 58 times sine 39 degree over sine 59 degree. Using calculator, it turns out that side A equals to 42.58 feet. That's the one possibility. And the another possibility is, if you apply the angle A equals to 23 degree, because our angle A has two values, two possible values. So A equals to 58 times sine 23 degree over sine 59 degree. Turns out that side A equals to 26.44 feet. Great. So I hope it makes sense to you all. So now let me summarize again. So in this diagram, we found two possible values of angle B. Then correspondingly, we found two possible values of angle A. Similarly, we found two possible measures the length of side A. Awesome. Now we finish this example 3. Now let's move on. Example 4. This is an application type problem. Let's find the height of mountain. Approaching from the west, means going from this way, from the west. This is east, this is north, this is south. Approaching from the west, a group of hikers note the angle of elevation to the summit of steep mountain is 35 degree. At a distance of 1,250 meters, this distance is 1,250 meters. Arriving at the base of the mountain, they estimate this side of the mountain has an average slope of 48 degree. So now this angle is 48 degree. Then obviously this angle is 180 degree minus 48 degree, which turns out that 132 degree. Great. Questions part A. Find the slant height of the west side of the mountain. So let's find out this height. This is the slant height of the mountain. how tall is the mountain? This is the actual height of the mountain, this h. Part C, find the slant height of the east side of the mountain if the east side has an average slope of 65 degree. And what is the height of this east side of the mountain if this angle is 65 degree? I hope the question makes sense to you all. So now let's begin the solutions. By the way, this 48 degree is given to us. So then 180 degree minus 48 degree turns out to be 132 degree. And in this left side triangles, the sum of this tiny angle plus 132 degree plus 35 degree is 180 degree. Right? The sum of three angles of a triangle is 180 degree. Then this unknown angle equals to 180 degree minus sum of these two angles, which turns out that this angle is 13 degree, which I did here. Which I did here. So apply the laws of sines to find this slant height of the west side of the mountain. So by the law of sine 13 degree over the side 1250 equals to sine 35 degree over this side h slant. Let me scroll down this way. Then cross multiply h slant equals to 1250 times sine 35 degree over sine 13 degree. So I cross multiply and again I rearrange the terms here. Then I got h slant equals to this ratios. Using calculator, it turns out that the height of the west side, that the slant height of the mountain of the west side is approximately 3,187 meter. So we found this height is 3,187 meter tall. I hope this makes sense to you all. Next, let's find the actual height, this h here, this height h of the mountain. So part B, from the middle right triangles. So here is a right triangles here. This one 90 degree here and 48 degree, 90 degree. Then we can apply the trigonometric functions, the sine functions, to find this height. We know this one is a hypotenuse. We already computed in part A. I'm talking this middle right triangle, okay, here. This is my perpendicular, this is my hypotenuse, this is my base. If I apply the trigonometric functions, sine functions in this right triangle, then sine of 48 degree equals to perpendicular over hypotenuse. And perpendicular is the h we need to find out. Great. So here, so the sine 48 degree equals to perpendicular over the hypotenuse. Perpendicular is h, hypotenuse is slant height. We know that h slant is value we already found here, and h we are going to find out. So then by cross multiplying and rearranging, h equals to sine 48 degree times h slant. We know the h slant in by part A, 3,187, then times sine 48 degree. Using calculator, it turns out that actual height equals to approximately 2,368 meter. So we found this height. So now finally in part C, we need to find out what is this slant height of the east side of the mountain, which I denote by h east. Great. So now this angle is 65 degree, this is 90 degree. We can easily find out this angle if we need. Now here's again I apply trigonometric functions, sine functions here, because in this right triangles, sine of the angle 65 degree equals to perpendicular over the hypotenuse. We know the value of perpendicular already, then we can easily compute the value of this hypotenuse, which is slant height of the east side of the mountain. Great. So let me move on. So here. So from the right triangle, sine 65 degree equals to h over h east. Let me show you again. Sine 65 degree equals to perpendicular over hypotenuse, that is h over h east. Here we know the h is by part B 2368 over h east, hence h east equals to, by cross multiplying here from first and the last, h east equals to 2368 over sine 65 degree. Using calculator, it turns out that h east equals to approximately 2613 meter. I hope this computation makes sense to you all. So we finish the sine laws in today's class, and in our next class I will cover the laws of cosines. One more time, to solve non-right triangles we need the law of sine and law of cosine. To solve right triangles we can apply trigonometric functions. There are 6 trigonometric functions. Great. Thank you.